your work or your workflows, your ideas is low code. So back in the days, we used PowerPoint. We wrote in 2, 3, 4, 5 steps. Okay, this is what you do next, engineer. This is how you get your job done. Now you don't have to do that anymore. Our roles as engineers evolving is that we become less faceted. We become more generalists. So we'll become decision makers rather than executors. And I always believe that, wow, I'm an engineer. I have to design things. I have to calculate things. I have to use integrals and math. And, after 10 years in the industry, or even longer, I just realized that that's not what makes projects or products successful or people successful. It's communication, it's insights and knowledge that help you to make the right decision at the right time.
Mike, welcome to the Connected Engineering podcast. Today we'll talk about simplifying mechanical engineering with modern technology. So first of all, welcome to the show.
Thank you.
So can you give the audience a little bit of a background? Who's Mike Grau and what are you actually doing at Synera?
Of course. Who am I? What am I doing? I'm a mechanical engineer by trade. I studied in Germany with a focus of automotive engineering. And by surprise, I somehow ended up at an automotive OEM at my first job. And I never wanted to do that, but I kind of liked it. So I stayed with it. And I don't know how it happened, but I somehow went back to the software industry where I started my career years ago when I studied. So I joined a software company and really like developing new technology in cooperation with customers and partners. So I worked in the software industry for the last 10 years, traveled around the world, moved from Germany to the US back and forth multiple times, and had a chance to work with a lot of great people and work on a lot of great projects. And it always intrigued me how fragmented and how manual the workflows are that we are trying to develop. And that really motivated me to look for something different. And then someday I heard about that company called, back in the days, Elise. And, I just looked at their software and thought, okay, wow, this is what we need to do. This is the future. So it took a little bit longer, but at some point, then I finally had the chance to join Synera then in the tech sales team. And here we are. So
exciting story. You talked about software a little bit. I want to maybe ask you the question. There are some things the software development has done in the recent years, how software development is being done compared to how hardware development is done in the engineering space. What do you think is the outdated part of hardware development, how it's done at the current stage? Also regarding fragmented tool landscapes, for example, that Synera is solving.
Yeah, I think the way how the industry operated in the last decade transitioned a lot from the previous century, but still though, these workflows that every partner in a sequence accomplish is fragmented. They're all disconnected. They have to communicate through emails, through file formats, even though if it's just the simplest task of creating a tool that does molding. These workflows are so fragmented and that fragmented piece really causes a lot of time and disrupts it. It extends the time to production, extends the time to market of a lot of things. And I think software progressed much faster. They had the chance to because they don't carry the burden of hardware with them. So they went from agile now to DevOps, and the next theme is on the horizon already. So we're progressing faster, and faster. And hardware has a burden to keep up with that speed. And I think this is really where hardware can learn from the way how software develops. But still, they carry the burden of physical parts and components, and that is distributed all over the globe. So not as easy as software, but I think hardware can learn a lot from software.
Absolutely. Do you feel that there's a bit of pushback now with this new, I would say, new quote unquote movement coming, where it's like you want to adapt kind of the procedures or the processes from software engineering, but the engineers are going to be like, well, never change a running system. Why would I even try it in the first place? We have our Excel sheets. We're quite comfy. Why would I change?
Yes, absolutely. I mean, a lot of companies out there, they had a long time to improve their own processes, and they came up with plans and strategies. And back in the days, it was the best plan they could come up with, and they were great plans because there wasn't a tool like Synera, there wasn't visual programming, they haven't had that. So now they have to, really get back into that shoe of re-innovating their own processes. And that means that all the things they have done, they have to question how can they improve them even better. But they have set themselves up for a track. So they are on a specific track, the way how they innovate and improve their own processes. And to pivot to new technology is an enormous effort for them. Not only on the research side, but also on the mental side. So that's really the big challenge, is that the technology is ready, but you have to convey that message to the people. So the people mind has also to change.
What are some of the objections, especially you in the sales department, I would say, what are some of the objections people have? Well, we talked about never change a running system. What are some of the other objectives people have, objections people have?
Yeah, that's a great question. The objection most of the time is that, yes, we have already invested a lot of money in this soft system and this software, and how can you prove that it will be really more efficient? Or now we have to train someone else on your software, and now it's another software that we have to learn, and all those things they go on and on. I mean, the number of objections is endless. But among all these objections, you sometimes hear these people asking more questions because they get curious. There's interest. Okay, maybe there's something that we missed. So these objections that we hear, they actually help us to question the status quo.
Actually, that makes sense. I think when we talk about the engineer itself, like also the job aspect of an engineer, do you feel engineers will need to learn more the coding side of things? Because that brings us to the topic of low code, right? So engineers don't really need to code. They have kind of building blocks like in Simulink that they can connect tools and so on and so forth. How do you think the job of an engineer will change in the future? Maybe kind of a Mike prediction in 5 to 10 to 50 years, maybe.
I've done that a couple of times, but people were not a big fan of my vision. Said that's too futuristic. But no, the way how I see our roles as engineers evolving is that we become less faceted, we become more generalists. So we'll become decision makers rather than executors. We'll be in front of the screen, presented by information and insights. And those insights come from the workflows that we build. And the engineer won't be the person who just builds an FEA model, does CAD modeling, or creates tool paths for CAM program. No, it will be all done in the machine, and the engineer in front of the system will just make the decision. What is the best path forward? Like knowing all the insights from IoT and everywhere. And I think that's a really big change that the industry will go through in the next 10 to 20 years, is that they don't look for a lot of specialists anymore. They look more for generalists. People have a big picture, because all that specialist knowledge that we possess as engineers in all our disciplines will converge into the software.
Yeah, that makes a lot of sense.
It doesn't mean that yeah.
Go ahead.
No, it doesn't mean that we don't have to have specialists anymore, but these specialists, they will actually write the code. So in visual programming, and we also still have software developers, of course.
That makes sense. Maybe from your own perspective, Mike, how did you change maybe as a person, as an engineer, to become more of a generalist rather than a specialist? Like what transition did you go through?
I think it was my mind. I had to change a lot of things in my mind. I always believed that, wow, I'm an engineer. I have to design things. I have to calculate things. I have to use integrals and math. And, after 10 years in the industry, or even longer, I just realized that that's not what makes projects or products successful or people successful. It's communication, it's insights and knowledge that help you to make the right decision at the right time. And I think that's the thing that I had to challenge myself, is that, like, I can't know everything, even though I want to. I would like to be the specialist in all fields or some fields. And no, it's not going to work. You'll never be the specialist. It doesn't matter how hard you try.
Yeah. So it goes back to kind of the soft skills. I think some of the people would be interested, like, what do you recommend to people, like, gaining more soft skills rather than the hard skills, solving integrals and Navier-Stokes equations and whatnot by hand? So what can
Yeah,
people
yeah.
actually do to increase their soft skills?
I think that's a really big challenge for engineers. Engineers usually are focused on the facts, the technical side of things, and pushing an engineer towards the communication side. What is really important nowadays? That's a hard that's a hard task to accomplish. Yeah, how did I do it? Yeah, I pretty much learned on the job. So I looked at other people. I just reflected. I've completed project, reflected. What was the problem in the project? Why has this project been delayed, or wasn't the outcome as good? And it had a lot to do with communication, with expectation management, rather than some stress failure in a part led to a crack. No, it was never really the issue. It was communication. It was really the interaction between other disciplines, other engineers. And I think what people can do is, and this is what I did, is that jump between multiple disciplines, work with a lot of different people, and gain everybody's insights. Like pick their brains, but become friends with them. So that opens us up a lot of doors, and it opens your mind to. So it helps you. And most important is listen to the people. Just really listen what they say, and ask questions, and then you understand their problems, and then you understand how you can help them. So this is when interaction starts to happen, and that is when your horizon becomes larger, much larger than before.
How can low code in this case then kind of be the enabler to, I really hate the word, democratize knowledge in that aspect, because democratize is kind of a word which has been cannibalized for the last couple of years, I
Yeah.
would say, or multiple years from the simulation industry. So how can low code actually help us engineers to kind of make knowledge more accessible?
Yeah, that's a great question. I'm a big fan of centralizing knowledge. The knowledge that all of us possess, um, it will vanish as soon as we jump into a different role. It will vanish as soon as we leave the company, or start our own startup. The only way how to capture that knowledge is you document it. And as a software developer or engineer, you have to document what you do. If you go back to the things you have done yesterday, in 3 months from now, you won't you won't even know what you've done. So documentation is important, and the way how you can document your work or your workflows, your ideas, is low code. So back in the days, we used PowerPoint. We wrote in 2, 3, 4, 5 steps. Okay, this is what you do next, engineer. This is how you get your job done. Now you don't have to do that anymore. You just put a low code. So the engineer doesn't have to do it manually because someone already has done it for them. So the automation. So building the logic is one thing, but building also the automation of a process. And I think that's really where knowledge can be captured and built on.
Absolutely. When I think about some of the engineers, I don't want to generalize too much, is that some engineers are very hesitant to actually give away their knowledge for free and kind of embed it into something like a low code application. And I've asked this question multiple times on the podcast so far, but I want to hear
Yes.
your perspective, Mike. Why do you think engineers have this kind of mental barrier of giving away knowledge? Because they think, well, if I might leave, I'll take the knowledge with me. Why would I leave it in the company? Because I'm the genius here, so I should keep the knowledge for with me forever. What do you think a mental shift? There has to be a mental shift for engineers to actually overcome this. Well, everything is mine. I want to keep it.
Yeah. I mean, this is what they do. I mean, they go to university, they study, they learn, and then they possess a certain knowledge, subject matter expertise. This is what they get paid for, right?
Yeah.
This is what the industry paid for, subject matter expertise. I think that's really the challenge for a lot of people, that to walk away from that past path that they've chosen, and shift to that new, as you said, the new mental models. Like, hey, we want to make everybody successful, and my expertise, knowledge that I possess, that's not the core value that I bring to the company. The core value is that I help people to understand that we have to document and shift to that new way of things. That's, I think, yeah, why are they so behind? I think it's just really money by the end of the day, because you get paid for your knowledge, right? So you get hired away. but now you have to put your knowledge into a system, and now you're losing actually your uniqueness. But what people have to understand is like your new uniqueness is that you understand how you are able to capture your knowledge and put it in a documented workflow. And I think that's what people have to understand. This is not that you possess knowledge; it's that you understand how to document and make sure that everybody can access your knowledge. I think that's a shift that needs to happen, but that will need time. And people and also companies need to recognize, okay, this person knows low code, it knows Synera eventually, and understands how it can capture someone else's expert knowledge, captured it, and automate in Synera or in any low code platform or environment. And I think this is really the added value, and this is what people see as a valuable engineer, rather than someone who just possesses subject matter expert and can just leave within a split second the company.
Yeah, absolutely. That makes sense. We talk about a specific use case, Mike. In the beginning, you talked about the fragmented tool landscape. Do you have a use case of like a quote unquote half-baked solution, which then was transformed or like enhanced, I would say, maybe augment is a better word, using Synera, a low-code application? Maybe something like cable routing, for example. Let's take that as an example.
That's a great idea. I mean, there are a lot of tools out there who do similar things. So you voxelize design space and then, estimate a path along the narrowest route. There's a lot of different technologies out there, but they only do segmented tasks. Like for fluid mechanics, it's the same. You design a voxel space, apply boundary conditions to it, and somehow the solver will find the best path with the lowest pressure drop. That's just one discipline, but there's so much more in front of it. There are design criteria, there are manufacturing criteria, right? Like once you have designed your part, you send it over to the manufacturing partner and they tell you, well, we can't manufacture it. It's impossible. Or maybe the cost engineer tells you, well, I can manufacture it, but it's going to cost $10,000 and we'll be out of business next week. So all those things that you really need to have in a closed loop workflow, all the information you have to have actually that are critical when designing something, that's information that you can now have in a low-code platform. And I think that really makes the approach of low-code unique, that the segmented disciplines will now be able to gain information from other disciplines and improve themselves. So a segmented discipline by itself is dumb, literally. It does just one thing, and it is only smart because of you in front of the screen. But what would be much better is that if this discipline gets informed from downstream and upstream, that makes the whole outcome much better.
Yeah, I see. So basically, you start kind of with a Lego building block, but you build on top of each other. So it's kind of an iterative process and it becomes smarter over time, kind of a self-learning thing, so to speak, with different departments and knowledges.
Exactly, yes. So it has to start somewhere. It's a chicken and egg problem, but you have to start somewhere, and then you start connecting bits and pieces. I've never seen someone building a workflow just one out of the box, just right away. Here it is. That's my workflow. No, it never started that way. They started somewhere in the beginning, at the end. Most of the time, I see people starting in the middle. Surprisingly, but this is the best place to start. And then you start adding pieces on top, on the side, and change things. It's an organic thing. It grows. It changes, and that's so unique and that's so different, I think.
I like the organic analogy, and I think we should also mention, Mike, that there's also templates inside of Synera, so you don't really start from scratch, almost from scratch, but there's obviously help and an academy to get you up to speed to actually learn the tool.
That's right. I see that a lot of times that people use these, as we talked about, building blocks. Those are the templates. And when we talk about starting building a workflow, maybe they just started with a template and then put their spice in it. And then they think about the next building block in the chain. Well, they sometimes have to program that self, but with the nodes we have, and then use another template on top. And that's how these building blocks come together.
Yeah. Absolutely. What was kind of the wow moment for you, Mike, when you you started using Elise? Maybe back then it was called Elise, now it's called Synera. Maybe a use case, or maybe where you thought, wow, this is amazing. Like where you use different tools. We talked about the fragmented tool landscape where you were like, man, this is amazing.
Uh, I can show you something.
Go for it.
So I've been working a lot with lattices in the past, and
Nice.
one of the issues with lattices is that the industry is completely focused on meshes and explicit modeling. And the problem is that in the industry that is not the file format that you can use in FEA. So whenever you design something, an FEA engineer may ask you, okay, so how do I run that now? How do I run this simulation? And I always try to overcome this problem. Additive structures are so light, but you can't really get the maximum out of it because you have the simulation barrier. And this is when I run into Elise and just figured out like, hey, there's a way to create these structures in surfaces or create lightweight FEA structures very easy without just having 2 or 3 software developers behind me and telling them what to do. I can do it myself. I haven't had to hire people to create a tool that is literally a black box by the end of the day. I would not be able to understand it. I wouldn't be able to change it, even though I wanted to. I would have to hire someone. But now I can do it myself. I can build an algorithm that does that. And I don't have to study for it, and I don't have to be a software developer. I think that was a big aha moment. I could actually do it in 1 hour instead of just 3 months. And because all these building blocks, all the nodes you need to create this, it's already in Synera, and you don't have to start from scratch in a C library or Python library. And I think that was a big aha wow moment where I thought, okay, wow, this is a game changer. This could be a game changer for a lot of people who run into this problem.
Definitely, yeah. Super cool insights. I'll also link or will link to some of the use cases or workflows then on the website that people can check out and try for themselves. To wrap it up, Mike, any closing remarks from your end? What I always like to say, like some motivating words to the engineering community out there. Maybe in try Synera, there's a 14-day field trial. What else would you tell them to close the podcast?
Yeah, think of your dream workflow. Think of the things that you always wanted to do. Scope them out first, and then just start somewhere. Start in the middle, learn the software, and then build on top of what you started with. And just after 1 or 2 weeks, you just look at what you've done, and you think, well, wow, I did that. I think that's the most satisfying moment for an engineer when you realize how much power he gained by learning a new skill, a new task. Even though it might be painful in the beginning when you always learn a new task, but the outcome is amazing. I think the outcome you can see by doing it is much better than anything else.
Absolutely. I think with that, we can wrap up the podcast. And one thing I have to add here, Mike is trying to become kind of a LinkedIn influencer for the engineering community, kind of a spokesman for Synera.
Right.
Trying his best. So I'll also make sure to put the link to your LinkedIn profile down in the description so people can follow you and keep up to date with the latest Synera updates, but also obviously reach out to you in case they have any questions, Mike, right?
Yes, absolutely. Looking forward to, hear from you through LinkedIn. This is my preferred tool.
Amazing. Thank you so much, Mike, and hope to see you in the second part, hopefully in the future.
You're welcome. Thank you.
Thanks.